Today I am going to show you how to use Google Earth Engine for image classification. I will be using the random forest machine learning algorithm for image classification, and we will be using the Sentinel 2 data for this particular exercise. So I have a basic framework ready here. Some code has been already written. I will be adding some data and we'll be doing some pre-processing, and then we'll go for the image classification. So I will start with selecting a small study area. I'll navigate to some random places here, and then let's say somewhere here we'll choose some area. Let us select this particular area. We have some forest, some cropland here, some water bodies, and it will be associated with some sands. So this we will call as our study area. Now I'll add our Sentinel-2 data. So it's already added here. We have taken the March 2021 image, and we have given a maximum cloud cover percentage as 20%. Now what I will do, I have this entire code written here. Before I run this entire code, I'll add comment to some lines. So from here to end, I'll comment these lines. Let us just select our images, and then we'll see what are the next steps involved here. Uncheck this. So this is our study area. Now I'll run this. It will try to find out suitable images available for this particular time frame and for this particular area. So you can see we have 6 images available here. You can see their image acquisition date here. This is the image acquisition date, 2021 March 5th, 10th, 15th, 20th, 25th and 30th. Now for our image visualization, we will be using the standard false color composite format. So in Sentinel-2 data, this band 8 corresponds to near infrared band, band 4 is the red band, and band 3 is the green band. And this particular value, we are like plotting our study area shapefile here, and this value indicates the zoom level. So I'll just make this as a comment so that I can easily move within my study area. So the first thing is we have added our image and printed the images, where we could get 6 images. Now we'll see which images are cloud free. Although we have given a cloud upper limit threshold value, but still we'll check which images are useful for our study or entirely cloud free. So to do that, I will just create a list of images, and then we'll read each images one by one and plot them, and we'll select which images are suitable for our study. So these 2 lines are to create a list of these 6 images which we got for this particular time frame, and then we'll print them. So if you see, this is our list of images, 6 images. So it's very simple. You have to take the image collection, then to list, then image collection dot size. So it will create a list of images you have, and we have then printed it. And now we'll take images one by one and see which images are cloud free and which images are not suitable for this particular case. So I have just added a line here to mark which images are cloud free. So before I prepared this video, I tested it out, so I could found these are the cloud free scenes, but still I will again recheck them. So to add an image, you have to use this command e.image and then just define the list and then get 0. So once we press create 0, so from this list it will include the first image and then it will clip this image based on our study area shape file or vector file, and then we'll plot this. So to plot this, we have this image variable followed by image visualization and a name which will be appearing in our layers. So now if I run this, you can see in layers we have this SFCC image 1 which we named here, and it is showing our cropped image. So this is basically standard false color composite image. So you can see like in background map, if you see these are forest areas, but in our image those are appearing as a fallow land or barren land kind of classes. Basically this is the leaf fall period in this region, that's how it is showing a higher background soil reflectance and has a different color than a forest area with good canopy cover. And other features you can identify, this is the river, but if you compare it with the background Google map, you can see there is a like significant difference. The river is not that wide, it's very narrow, and there is some your sand deposition. There are some croplands associated with this river body, and there could be some fallow croplands also in between. So we are going to take these basic classes for our image classification. So we'll be considering forest, cropland, fallow cropland, sand, and water body. So you can take as much as class you want depending on your study area and depending on your study. So you can see this first image is cloud free scene, so we can consider this scene for our image classification. Let us check other images. Let us check the second one. So we'll just mark here 0 as our cloud free scene. The second image is not a cloud free scene, and there are some edges also. We'll not use that scene. Let us check the third one. Yeah, it's a cloud free scene. Let us check the fourth one. Sorry, the count starts from 0, so 6 images, it will be counted from 0 to 5. This image again is not clear enough. Yeah, this is a clear scene. We'll use this. Let us check our last image. Yeah, this is again a cloud free scene. So these cloud free scenes we can use in our image classification. So one can use a single time period image or a multi-temporal images. I personally prefer to use multi-temporal images for a better image classification, where a single time image may not be able to capture all the classes very well, or there could be some chances of image misclassification. So it is better to use multi-temporal images depending on the, and the images should be decided depending on the study area, the time, the season. So all of those things needs to be taken care while selecting the images for classification. Now I'll create an image collection. So earlier we had 6 images, but now we could found 4 cloud free scenes. So now we will create one more image collection using these 4 tiles, 4 like images, and then we'll create a layer stack of all these your images. then we'll use that for our image classification. So I'll remove this comment from here. To create an image collection, one should use this command image collection, and here we'll use the same thing used to select images. So we'll start with 0, then comma 1, sorry, earlier will be 2, and 5. So these 4 images we will be using to create a layer stack, and in the same step we will be using only 10 meter and 20 meter bands. So you may be knowing the Sentinel 2 data as 10 meter, 20 meter and 60 meter bands. So you can just go in Google and search which bands are having 10 meter and 20 meter resolution. So our band 1 is having 60 meter resolution, and 9 and 10. So excluding these 3 bands, all are 10 meter and 20 meter. So you can use all the bands excluding band 1, 9 and 10. So we'll just in the same line just write here our band 2, band 3, band 4, and 5, 6, 7, and 8, and 8A, and 11, and 12. Let me just confirm this. 2, 3, 4, 5, 6, 7, 8, 8A, 11 and 12. Yeah. So and now we'll create a image stack using these selected bands and those 4 cloud-free scenes, and we'll print that to check the number of bands. So we have used a image collection. So our image collection is ready. It contains 4 images, and if we check the bands, you will find only our selected bands are there. Band 1, 9 and 10 is not added here. Now we'll create an image layer stack. So to do that, we have this simple code here. I'll be sharing this code with everyone. If anyone can wants to follow this code, they can use this. So yeah, so this is our image collection variable where we have kept our 4 cloud-free scenes. Now I'll use this one for our image stacking. So this code you can see and learn how this works. If you run this, we'll get a image stack. So first we have created a function, and that function, the stack collection, we have applied over the image collection. So that's how one can get a image stack. Now you can see there is only one image which contains 40 bands. If we check the bands, the initial bands will be band 2 to 12, and then the successive images will be added with band underscore 1, then band underscore 2, and band underscore 3. So now our image stack is ready. We can use this for our image classification. So to create a classified image, we need to create some training data points. So as I told initially, we'll be considering 5 classes as forest, cropland, hellowland, water body, and sand. So for these 5 classes, we have to generate training data points that we will be using for our model building as well as for our accuracy assessment. So we will be using the shape files or point shape files basically, or point vector files to denote our input training data points. So we have to create the training data points within our study area. Let us create a new layer. We'll rename this as forest, import as feature collection, property, add a property name. You can use class or any other name you want, but don't use class with a small c in the beginning, then it will be classes with Google Earth Engine syntaxes. You can use a capital C if you are using class as a property. So I'll just assign a value name value 1. This will be our first class. We'll be generating point shape file. So I'll use this pointer. I'll zoom in a bit and we'll try to create at least 30 to 40 training data points for each classes. So part of them will be used for our model development and part of them will be used for classification accuracy assessment. So we can randomly create training data points. You can see the numbers here, how many points you have created. Take samples from different locations so that it can capture the class diversity. Now we have some 51 samples. So this is our class 1. Let us create other classes. Forest, then we can add cropland. Class name 2, we can assign a color here. Yeah, these are all grasslands which are bright in bright red or pink in color. These are all cropland areas. We can take samples over here. Again, we'll try to capture at least 30 to 40 points. Yeah. Let us stop here and then we'll create similarly training data points for fallow land. Similarly, let us add training data points for water body and sand. You can click and drag these images, and then wherever you want to choose your 10 data points, you can just add samples. You can also consider some inland water bodies. Let us take some sample here and also will capture some water bodies. Yeah, these are the inland closed water bodies. We can also take some samples here. So these pixels will be then well classified. Let us stop here and take one more class as sand. Yeah. These bright white pixels are basically sand. Yeah. We'll stop here. So we have now created our training samples and you can see them in the beginning. You can see all our 5 classes are here, the training data points for all these 5 classes, and you can see the number of points taken for each classes. Now we have to assemble these images. Oh sorry, you have to assemble this your training points to create one set of training data points or training samples. So we will be using this merge command. Our first class is forest, that will be merging with cropland, then merge with, sorry, it will be a dot here, cropland hello, and then water body and sand. Yeah, so these are our 5 classes. We'll be merging them, and the variable is polygon. So with the, let us replace this with points. Yeah, these are point training data points. So yeah, here also. So we are merging these 5 classes into one shape file or one vector file, and you can some error in this class water body. Yeah, it's W is small here. Let's keep capital. Yeah, this is our training data points, you can see 199 samples or elements have been captured here, and now we'll segregate this data randomly into two parts. One will be used for our model development and another will be used for validation. So first, to create a randomization, we'll be using the function random column, and then the random numbers less than 0.8 will be using for our training sample, and more than 0.8 will be using for our validation sample as a validation sample. You can just print them and see how many points have been categorized into these two categories. So out of this 199 points, 156 points have been used for our training and 43 for our validation. If you want to change this number, you can change this random code values, so you will get a different set of numbers for your image classification and validation. So let us use 0.75. Yeah. So now 147 will be used for our model development. So basically we are using this filter function to segregate these two data points. Now we have to extract the values from our stacked images for these training data points. So this is a very simple code. This is our stacked image underscore stack, and then sample regions. This is the function or code to extract the values, and our collection or the points is the training sample, this one. Property, we have assigned the property name as class, and the scale you can define as 20 meters, like most of our bands are having 20 meter resolution. So, and you can print them if you want to see the values, extracted values for each of those points. Similarly, we will also extract the values for our validation data points. So if we run this, you can see this is the training data points band values, and you can open each of these features, and in property you can see the band values has been added here, and also the class, also it is indicating the class number basically. Now we are going to build our random forest model or classifier. This is the part of that code. So our training data point is ready with the image pixel values or DN values, and the code to create a random forest classifier is very simple. e.classifier.smile random forest, and this is the number of trees you want. You can change it to any values, and there are some other indicators if you want to apply here. You can go ahead and adding them. You can search this function and you can read about these other functions if you want to try them. And then we have to define our training data. So it will be dot train, and our training data will be collected from here. This is the training where we have extracted the values for our input training data points, and then we have to define the property, that is the class or the individual identifier of the different training data points. So this one single line will create a random forest classifier, and then we can apply this classifier on an image using this syntax or like classify. So using this code we can apply the developed random forest classifier on our image underscore stack, and we'll create a crop, or we'll be clipping this using our study area boundary. So if you want to print the classified image just to see a very few basic details, you can print it. Otherwise, we need to print this, and then we have created a palette. So for our 5 individual classes, we'll assign a color and then view that. So green will assign to forest, yellow to cropland. Let us assign a fallow land here, blue for our water body, and then gray to sand. Yeah. So this map at layer is used here to visualize the map, where we'll be using this palette developed here, and then the minimum maximum values, which is 1 to 5, and then a name. If we run this, yeah, so here is our classified map, and you can see the different classes classified here. This is the forest, the croplands, fallow lands, water body, and some sand near to that river. Now we'll check the accuracy. So if you want to check the accuracy of the input training data points, that also you can check. And if you want to measure the accuracy of the classified map, for that you need to use the validation data points or testing data points. So we'll apply the classified the developed your random forest classifier on the validation data points to classify those validation data points, and then we'll compare with its actual class. So this part is not necessary. This is the accuracy assessment for the training data points, which will be always 1, but let us check the accuracy for our validation data points. So our data points are available with the variable validation, so we'll classify the validation data points with this RF classifier model we have developed, and then we'll create an error matrix. So you can use this particular format, and this is the class name, which is like class property, which is class for our case, and then you can print the error matrix and accuracy using this is your code. So if we run this, we'll get the accuracy assessment for the classified map. Yeah, so our overall image classification accuracy is close to 98%. You can see the matrix here. So one point has misclassified here, so that is giving this 2% inaccuracies. So now we can also visualize the variable importance, the importance of individual bands, how they are performing, or what is their contribution to this classification for different classes. That can be printed, and we can use this simple function here to print a chart that we can also use to prepare a chart based on the variable importance or the contribution by different individual bands. So to that, we'll be using this explain, this function that will apply to this RF classifier, and that will use to get the importance, and then this variable importance will be using to create a chart. So if we run the code again, You can also see the trees created to classify individual data points, that also you can visualize. And also here on the left hand side you can visualize the variable importance or the contribution from different bands. If you want to export it, you can click here, you can visualize, you can compare there your contribution. You can download it in CSV file or you can download in a PNG file also here. So this is the code to create a chart, and if you want to export it, you can also go ahead exporting this classified image, and that you can export to your Google Drive. Thank you. I hope I could explain the use of Google Earth Engine for image classification using random forest classifier. I hope this will help you. Thank you. Bye everyone.